Okay, so first off, what are we doing here? This is called difference quotient. The difference quotient. Well, we actually kind of did a little bit of this before, and we're going to have a lab associated with this, but it's about moving functions around. Do you get that this might have been a parabola that got moved to the right and up a little bit? And that this might have been the square root function that got moved to the right and up a little bit. And this might just be a plain old-fashioned chunk of line right here. That guy was just a y equals x function, except it's got a negative slope, so it'd be like y equals negative x, and then it's been moved up, because the y equals negative x would be here, and then it's been moved up. See what I mean? So basically, it's just shifts of functions. And then this lab is about building a Franken function, also known as a piecewise defined function, that'll be part this, and part that, and part that. So if I wanted to do this lab in 15 seconds, I would go, okay, well, I need to have one of those. Okay, I'm already too late for the 15 seconds thing, but I just need to have one of those functions where it's f of x gives me three things. And it's going to be negative x, and then I got to move it up some. Let's say I'm looking at the y-intercepts here. Maybe it's negative x minus 40. That would make it have a negative slope. And then this part right here, that's a parabola, except it's been moved to the right and up. So let's say I go like minus, how far to the right do I want to move? I don't know, let's say that's like 20. And then up a little bit, plus, what's this number? I don't know, let's say 5. There, I'm writing a piecewise function that's going to build a roller coaster. You get the idea? You have to be more careful than I'm being right now, but this last part's a square root of x, except I need it to start right here, so I figure out how far over and how far up to move it. Let's say I move it over like 25, and then I move it up like, looks like that's 10. And there, I've got it, I just don't have my domain. It seriously can go quick. I know I went really fast there, but you're going to have time to take your time and figure it out. What are the key elements to this? The key elements are, how high do you want it up? Well, look, it says right there, it wants it at 10. You get that that means this function, the dividing lines, this part of the function needs to stop right there at that point. That point height is 10. You have to figure out what that is, but you know what? You get to pick. You're making this a roller coaster. It doesn't say exactly how wide it is. Let's say you decide, I want that to be, well, I think I want it to be divisible easily. So maybe I want this to be 40 feet long. It's like a little kid's roller coaster, okay? It's not like meant to be massive. Or you could times this all by 100 and say it was in hundreds of feet or whatever. So anyway, if that's going to be 40, then you can go, maybe I want this to be 10, 20, 30, and 40. I mean, that's possible. You get to pick that axis. And then, you know, you want your point to hit right there at 20, 10, according to what I just did there. All right. And then how about this low spot? You can get as low to the ground as you want. It doesn't say, I don't think it says, how high it has to be off the ground, but it has to be off the ground. Your roller coaster can't go underground, even though you could actually do that in the real world. Here, we're not going to go below this x-axis. Okay, so you better get it. This has to be shifted up so that it's off the ground. All right. Do you get your new stretches and stuff too? Like if I want my parabola to not look like a normal parabola, I want it to be more steep, like more violent roller coaster. I can stretch that thing, and so I can go y equals 3x squared. That stretches it vertically. Does that ring a bell? Okay, now I'm going to give you the 2-second summary of all the changes you can do on a parabola. Better not use 3's the whole time. Do you get that has been moved to the left? Tell me more. It's also been moved, yes? Yep, left 8. Down 9. And this part right here, vertical stretch. Factor 3. Okay. Next thing. If I give you another one, I'll leave that up for a second in case you're copying it down. Y equals 3 times the absolute value of 2x minus 4. Do you get there are 3 things that have to happen to my parent function? I got to do this, and this, and this. And the order you do them in is a big deal. All right, this is the part where you got to take some good notes, okay? Because you want to know exactly what order to do these in. It's going to come up on probably 3 tests. Because the order of operations in math is a big deal, right? You can't just add first and then do multiply. You got to multiply first, then add. Same idea on these translations. You got to do them in the right order or the graph won't work. It won't come out the same. Just like you can go, if you do this in the wrong order, you get a totally wrong number, right? If I add these together and I get 7 times 3 is 21, if I do it right, it's 15 plus 2 is 17. 17 and 21 are different. Therefore, the graphs come out different if you do this in the wrong order. All right, so what order should you follow? I have a way that I think makes perfect sense, and that is, do you get this as like a parenthesis, and therefore we should start on the inside of it? So whenever you do your order, you should start on the inside of your function. So the first thing I should do is this. Okay, and now what is that 2? Remember, the stuff on the inside does the opposite of what you'd think. You would think, since the stuff on the inside is the horizontal, I don't know if you were taught this one, but I use high-vo a lot. Horizontal on inside, vertical on outside. It's kind of like the dwarf song, hi-ho, hi-ho, it's off to work we go. Anyway, high-vo. Horizontal on inside, vertical on outside. So the stuff on the outside, that's a vertical. That's a vertical. And it really helps you keep them straight, in my opinion. Okay, so that on the inside is the first thing, and it's a horizontal thing because of the high-vo. And that 2 means that it's going to be a horizontal, I almost said vertical, horizontal, and then it seems like it should make it twice as wide. Do you get that it doesn't do what you expect? It actually makes it half as wide. If you want to understand why, let me show you what I mean by this. Okay, do you get, if I was going to try to get the x alone, I would divide it by 2. So what does this 2 being here really mean? It's times 2, but to get the effect on the x, it's actually divided by 2. That's a way to understand why it does the opposite of what you would think. It's because once you solve it for x, to get it off of here, you're going to have to divide it by 2. So all of your horizontal values get divided by 2. It gets half as wide. Instead of being twice as wide like it seems like that would make it twice as horizontally wide. It's a horizontal shrink with a factor of not 2. Can't shrink something with a 2. A shrink with a factor of 1/2. That would be your first step on this problem. You might want to write this one all the way out for a good example of what order to do stuff in. If there had been 2 things on the inside of this function, do you think I would have done it in the normal order? No. Everything on the inside is opposite what you'd expect. So if there had been 2 things to do in there, I would have done it in the opposite of normal order. All right, I'm done on the inside. Now I move to the outside. I'm going to leave this person nameless, but I saw somebody looking at their phone. Put it away, or I'll take it away. Number 2 is, of the remaining 2 things, the 3 or the 4, the 3 is being multiplied, the 4 is being subtracted. When you're on the outside, you do things normally. Okay, it's what you'd expect. So wouldn't you expect the multiply would come before the subtract? Yes. And so on the outside, you do things in normal world. It's not opposite land. So I'm going to do that 3 next. How do I do that 3? It's a vertical, because it's on the outside, stretch. And if you left that, I'd have to mark it wrong, because you didn't say what the factor was. Factor. And when you're doing a stretch, you use whole numbers like 3. Vertical stretch factor 3. And the last thing, step 3, would be this guy. and that is down 4. Yes, I know it's vertical, but you could say vertically move it down, but there's only one way to move things down, so I'd be fine with down 4, or vertically shifted down 4. All right, I'm going to give you one that's trickier because it's got 2 things to do on the inside, and you tell me what you think the order should be. I'm throwing in a negative also. There. What order should that be in? There's 1, 2, there's actually 4 things that need to get done to this function. What do you think number 1, number 2, number 3, and number 4 are? I will tell you there's one thing where the order doesn't matter, but all the other things, the order matters. 2 of these things are tied, and therefore you can reverse 2 of the 4. I'll give you this further hint. There is a first thing. It has to be first. You can't like pick this or that to be first. If you're going to start on the inside, there's only one right thing to pick for first. Okay. Here I am on the inside. And what should be first? It seems like the 2 should be first, but we're on the inside where we can't trust the order of things. So therefore, it's not first. That's first. And this should be, if it's a -3, does that move it right or left or up or down, or what does it do? Right 3. That has to be first. If you said the 2 first, nope, that's what it would be if it was on the outside, but on the inside, you do things in the opposite of normal order. So the 2 has to be now, and this would be a horizontal, and would a 2 seems like it makes it wider, so it actually is a shrink. Factor, and shrinks can't be things like 2's, so factor 1/2. Horizontal shrink, factor of 1/2. Third thing, after I've horizontally shrunken this thing, I've done everything that's on the inside. So I guess I got to move to the outside. Of these 2, those are the 2 that are tied. They're on the same number. You get what I'm saying? Like, it's a -4, but it is 2 things. The negative is going to make it flip or reflect, and the 4 is going to make it stretch. It does not matter if you stretch it first and then flip it, or if you flip it first and then stretch it. I will tell you that in the real world, if you're actually graphing one, it is easy to stretch first and then flip. Just like in gymnastics. Stretch first. Okay, so that is a, it's on the outside. Is that horizontal or vertical? It's vertical on the outside, so vertical stretch factor, what are stretches like, 4 or 1/4? Which one sounds more like stretch to you? 4. Okay, and then the last thing I would do is the flip, and I would not want you to say flip. If that was the only thing wrong, I know what flip means, but you know what the official word is? Reflection. So reflect, and again, it was on the outside, and if you remember high bow, it's a vertical because it's on the outside. Vertical reflection. If you had to say what axis that was over, that's, if you're going vertically, you're going this way, reflection, that's across the x-axis. I'm going to put this in a different color to make it clear. You don't have to have that part. If you just said vertical reflected, it would have been good enough. All right, that's a challenging topic. Honestly, you can grab a lot of math teachers off the street and confuse them with the inside of this function thing, because everything's backwards of normal. It's not intuitive. So honestly, I've had math teachers argue with me about, and I didn't know at first either. I didn't know exactly where the order was. Once I got it down, I went to other math teachers, and they're like, no, you can do this or that. And it doesn't, no, it matters. It actually matters. And you'll have people that are math teachers that have trouble with this. So don't be surprised if you do. All right, this last one, I just want you to not even tell me all the word verbiage and everything, but if I had this is a trick question. I'd like you to draw an arrow and say first, second, third, fourth. What do you think is first? What do you think second, third, and fourth? First thing, I hope that's obvious. Start on the inside. So what's second, third, and fourth thing? All right, here's the trick question kind of part of it. Get that 5 there. Is that 5 negative? 5 is not negative. That's a plus 5. Do you get it would act the same as if I put a plus 5 here at the end or here at the beginning? That's the kind of the trick question part of it. All right? They'll act the same. Now, if that's the first thing, what's the second thing? Remember me saying that it's better to stretch first before you flip? But I did say you had a choice, so actually you can reverse these two. And then add comes after this multiply by, so that's the last thing. And we're on the outside where it's in normal order. Who had first, second, third, and fourth in an acceptable way? Okay, good. All right. So that's the order we have to do these changes in. And just a quick reminder about how that would mean 4, even though it seems like it's to the left, it's actually to the right. Stuff on the inside is opposite of what you'd think. That's right 4. That would be up 5. That's a vertical because it's on the outside stretch. And that is a reflect or a flip. If you've got all those down, then this lab that we're going to do, which I've just briefly told you about, I guess I'm officially assigning the lab today. It's called the Mad Mouse Lab for those eager beavers who want to get it over with like immediately. It's not going to be due for at least a week. Okay, so you have at least a week from today to get it done. But that lab has to do with just moving, shifting little square root pieces and to make a little roller coaster. All right, so enough about, oh, and whenever you do the lab, do you remember how I have those, don't look at these points. I have that thing that says, this is just in my notes here, in the actual lab folder, it has that format for all labs. The sketch is worth 2 points, etc. Use the one that's in the lab folder. Okay, there's a folder for this lab. This is just kind of an intro to the lab. Don't use these points. But if you're missing a sketch, you're going to lose points. If you're missing the procedures section, and I was really generous on this last time, procedures is where you say in words what you did. Like, first I built a function, or the purpose. Purpose was to build a roller coaster out of functions. Okay, that's a purpose. Then, this procedures. Oh, sketch should be next, I guess. Sketch. Well, that sketch is your actual roller coaster. It's when you're all done, it looks like this, and then it's got a parabola here, and then it's got a that there, and okay, and it does have some rules about your roller coaster. It tells you in the direction. All right. Then the procedures is where you explain what you did in words. You just say, here's what I did. Calculations is always worth more points because that's where you actually do it. That's where you actually grind out the math of, okay, so here's how I got this equation for my middle of my roller coaster. And the conclusion is like, okay, so here is my roller coaster, and reflections, remember there's always 3. If you just don't have 3 reflections, you're going to automatically lose points. Reflections can be, this was actually a lot harder to make a roller coaster than I thought it would be because it was really hard to connect the lines. That is one of the things you got to need them to connect. If you have a gap in your roller coaster, people die. So in this lab, I'm going to expect the gap, there be not be any gaps. So they better be like right up next to each other. Okay, so anyway, that would be a conclusion piece, for instance, is that it was hard to get the functions to match. That's one. You got to give me 3 things. But they can't be specific, like I learned to use functions. It's way too vague. All right, let's get to, if you're going to add a couple functions, f of x plus g of x, here's how you can write it. You can say f of x plus g of x, but there's another fast shortcut way. You can just say f plus g. If you say f plus g, you mean I want these 2 functions to be added. What's the answer to it? You actually take this, and you actually add them. x squared plus x plus 2. That's f plus g. What do you think we're going to do besides add the functions? You're going to subtract the functions. Here's a common screw up on these two subtracted. People go, okay, so it's f minus g, good. And then they go, it's x squared minus x plus 2. So many points in this class will be lost for parentheses or for negatives. This kind of has both. What did the person do wrong? What's wrong with that? That's not f minus g. Yes? Yes. And that will force that 2 to become negative. You get the difference? If I just slap in a minus, only the x of this turns negative. What it should be is that whole thing was a variable. I replaced it with a parenthesis, and then I drop in the x plus 2. That's why I keep saying when you replace your x with a parenthesis, to remind you, when you're replacing the g function, that's this. It's like you have a parenthesis there, and you drop the thing in parentheses. All right, that's for adding and subtracting. Now this, I ran you through this a few times last unit, so this today in particular should be pretty easy. Okay, this is called the difference quotient. Now, why is it called a difference quotient? There's the difference. And do you know what quotient means? Quotient means you divide by. Quotient, the word quotient just means divide by. I'm subtracting something and I'm dividing by something. The big fraction bar means divided by. That's what makes it a difference quotient. Now, I'm not going to try to explain to you exactly what this is. This is a calculus topic that finds the slope of a line. Now, you're used to finding the slope of straight lines, right? But in calculus, you find the slope of curving lines. Okay, now how can you do that? Well, basically, if I want to find the slope of this, if I pick an area over which to find the slope, I can just have 2 points. And remember how I said we're going to a lot of times use, here's 2 points, find the equation of the line through that? It's if I want to know the slope over this little zone of my function, I can find the slope from there to there. Or you can even find the slope of something at a point on the function. Like, what's the slope of it right there? That's one spot. What's the slope right there? And basically, you make a tangent line. Did you know a tangent line touches exactly once? You know, like I didn't even make those two touch, but they're supposed to touch just once. Tangent line there, and then you find the slope of that. All right, that's just a little quick of what you're going to do in calculus. What you're going to do in here is, you remember finding f of x plus h? You just take x plus h into the function. And then f of x, well, that's easy. What do people mess up? F of x is given to you. So how do people mess it up? They forget to put parentheses around it and distribute this negative. And then you divide the whole thing by h. All right. I want to do the one that's on the board here with you. So first step, would you agree that one step at a time we need to find f of x plus h? All right. So I've always told you, put an empty parenthesis right there, and then drop in whatever they tell you. So 3 empty parentheses minus 5, and what do they tell me to drop in? This is the part where participation would be helpful. What am I supposed to drop into the function? X plus h. There. That is f of x plus h. Should I clean it up a little bit? Yep, I can multiply it out. 3x plus 3h minus 5. There. Am I done? No, I'm done with the first step, which was finding f of x plus h. Now I got to find minus f of x. Here's the mistake people go. Minus, and then they just drop in 3x minus 5. What's missing again? Parentheses. There. That's subtracting f of x properly with the parentheses there. And then it's a difference quotient, so I got to divide by, and what do I divide by? Just h. If you simplify the top, you've got it. Everybody try to simplify the top. Do that distributive of the negative there, and stuff's going to cancel kind of nicely. do you get, once I multiply this out, it's negative 3x and positive 5? Because the negative distributes to the negative 5. So I have 3x plus 3h minus 5 minus 3x plus 5 all over h. And a whole bunch of stuff cancels. The positive 3x and the negative 3x are opposites, so they cancel. And the plus 5 and the minus 5 are opposites, so they cancel. And it's 3h over h, and the h's can cancel. And remember how I was telling you were finding the slope? There, we just figured out the slope of that curve. And the slope of that curve will be 3. I want you to look back at it. Isn't that an equation where the slope was 3? You might be thinking, so then why did I waste all that time? I could have just seen that the answer was 3 right off the bat. Well, all we're doing is proving that this works even for really complicated things that aren't this simple. You can find their slope. All right? Do you get that if it was like this, you could still find its slope and it wouldn't be that simple? The slope isn't just 3. Get what I'm saying? You can still use this process of f of x plus h minus f of x all over h to find the slope of even really more complicated things. You'll find that this is one of those things where as you get smarter, you realize they could have taught us this other way to do it, finding slope, that was much more complicated, but they didn't, because the problems were all so easy. You could just say, that's where the slope is, boys and girls. See what I'm saying? But when the problem gets more complicated like this, you can't just say that's where the slope is, because there's this factor in there too, and it's going to mess up the slope. All right, so when it's more complicated, you have to have more complicated tools. Finding the slope isn't just looking here anymore. Finding the slope is this. So, a typical question for tonight. Let's get there. Get to the homework. And here's where it says 3.1. No, this is all still practice problems, so there's the actual assignment. And it wants you to do, just wants me to add the functions. That's pretty easy. That plus that. Don't overthink the easy ones. What do you think this is asking me to do to the functions? Come on. Subtract them. How about that one? Divide them. How about this one? Multiply them. Yes? That's just saying f plus g of x. It's kind of like saying f of x, except it's f plus g of x. And I should have thrown that in there. I forgot that we used the of x thing when I was teaching it to you, but you're just adding the functions here. Don't overthink this. So it's that plus that. So it's x squared plus 3x minus 1. That's it. That's the first answer. You're just adding the functions. Here you're subtracting them, and I warned you about the whole don't forget to distribute the negative thing. You got to have parentheses and be careful with your negatives. All right. This next one, the two functions, just added a little tweak to make it more complicated. There's a function and there's a function. Okay, and you're going to add, subtract, multiply them, etc. Can you add these two right now? No, they don't have a common denominator. How do you get them to have a common denominator? How do I add x minus 1 plus 1 over x minus 1? Would you agree the denominator right now is a 1? A reminder on how to find common denominators. You multiply something on the top and the bottom that's equal to 1. You know, that's why we can multiply by that. That will make them have the same denominator. Do you think multiplying by 1 would work? No, that wouldn't make them have the same denominator. So I multiply them both by x minus 1. Now, they'll have the same denominator. And now, you can actually add them together. So, of course, in pre-calc, it's not just going to be as easy as this plus that. You got to find a common denominator and then add them. That's one of the reasons that I wanted you to get the top 20 skill down of adding fractions. You might have felt insulted by that. But if you don't know how to add regular fractions and find their common denominator, what happens when they turn into variables. You won't have any clue if you can't do it with regular numbers first. All right. And I feel like this is a little bit overkill, so I'm going to kill one of these problems. Number 19, you may skip. I don't need you to have that much practice on that. Now over here, this is that, what was it called again? Difference quotient, because it's got a difference in it and a quotient, a dividing, subtract and a divide. And I don't need you to do it on a zillion functions, okay? But let's just make your life a little easier by getting rid of these over here and here for sure. And then I'll cut out the middle one also. Just one more thing. If you look at this, do you get f of x is like y, and that's like the line y equals 6? I want you to think for a second. What's the slope of the line y equals 6? 0. That one comes out to 0. Now I want you to actually prove it by doing that. You can. It's just weird, and the answer comes out to 0. All right? I'm going to have you skip this one because some of you are going to go, I know the slope. Slope's what? 2. And it seems kind of dumb to have to do it so much work to get that slope. But this slope, you don't know. And I'd like you to figure out what the slope is for that function. So in other words, do problems 23 and 24. I'm just trying to tell you why. I know that the slope on number 23 is 0. I just want you to see that when you actually do this little process, it comes out to 0. If that one's too weird for you, do 24 and then come back to 23. All right, and then over here, this is where it adds a whole nother level of complexity, which is just that it's a word problem when you're doing the same basic stuff on a word problem. Now, because I need time to give you your tests back, I'm going to stop and not talk you through this, so you may skip these for now. And all it is the same exact stuff. It's just giving you a reason to stick 0 into the function, or a reason to stick 10 into the function, or a reason to figure out, P of 5. That's the profit if you sell 5 of the sodas. Okay, so it's some good real-world application stuff, but to save you some time right now, we're going to stop the assignment. Once you hit the orange page, you don't have to do the orange page, and you don't have to do anything after it. That's what everybody just said. You don't have to do the orange page or anything after it. All right, so we can skip that also. All right, so your assignment is just those first 3 pages, and I talked you through even some that you can skip in there. All right, that keeps your assignment doable, and that's all I have for you for today.